Hello guys, welcome to Airborne Education. Today we will be doing flight planning monitoring part 2. Stay tuned because in the end I will give some tips and tricks that I use during my ATPL examination. See you. Question 1. What is the minimum obstacle clearance value to be applied in the primary area for an en route phase of an IFR flight in mountainous areas, where the variation in terrain elevation is 2000 feet? I know since you see the mountainous area, you were gonna say the answer is 2000 feet, but unfortunately it is not, because they're asking for the variation in terrain elevation. So it's very different thing. I will put here a graph that you can see that you have to memorize this. And there's also another important thing that you need to memorize is up to 5000 feet on terrain. You need to put separation for 1000 feet. And after 5000 feet or higher, basically you need to put terrain separation 2000 feet. And that's it for this question. You just have to memorize these things. Alright, for this question, I will show you two ways of solving this question. It is very important to note both of them because one of them is really quick and it helps you save time during the examination. But on this specific question, unfortunately, it doesn't really help, but I will show it anyway because you may or may not use it during your examination. All right, so let's begin with the question. Given the following information, calculate the drift and ground speed, and the true track given is 20 degrees, true airspeed is 180 knots, wind from 60 degrees with 30 knots. So first of all, what I would like to do is I always set my flight computer. By the way, I use a Pulley CRP5 flight computer. I'll show you here. So what I first do is first I would like to put 60 degrees with 30 knots. All right, so I spin it until it shows me 60. Hold on. Yes. 60 degrees. I move my true airspeed to 180 and minus 30 makes 150. So I put a dot, red dot on 150, as you can see. All right, from then it's a little bit more simple. What you need to do is you will spin it to your true track. So our true track is 20. So if I set it, it will look like this. As you can see, right now it's on 7 degrees to the left. But be careful. The question gives us the true track, not the true heading. So your heading must be 7 degrees right to fix it. But if you move it 7 degrees right, you will notice that actually the deviation moves to 6 degrees left, as you can see. So basically, if you put 26 over here, like this, you see, and 6 degrees left, so basically you have 20 as true track. So now all we have to do is just read it. As you can see from here, it's 156 and 6 degrees left. So it gives us answer A. And it is the correct answer, I know. But before we see the correct answer, I would like to show you another version of the solution. So another solution to this and the faster way is with the calculator. But why it doesn't work is because we have the true track, not the true heading. And if you have true heading on your other questions, it is really faster way and it will help you a lot. So let's begin with the question. As we know from true track to wind direction is 60 degrees, so we have 40 degrees difference. And when you're working with the ground speed, you have to work with the cosinus. And if you're working with the drift, you have to work with the sinus. So let's begin with the ground speed, so to make it simpler. So we will do cosinus 40, equals, which is 0.766, something like that. You should also get the same answer. So times with the wind speed, which is 30, equals 22.98. So if I just do minus 180, our ground speed will be around 157. As you can see, like there is small difference because it's, as I said, it's true track. It's not the true heading. But you can find it the ground speed like this. Now I will show you another technique how to find the drift with the calculator. So stay with me. You have to do basically the same thing with the sinus. So we know the difference is 40 degrees. So I will say sinus 40, which gives me 0.6427. Basically, I will multiply this number with our wind speed, which is 30. Then I will get the answer like 19.2836, something like that. Right now it's important because this is the formula where it begins. So I will multiply this number with 60, so times 60, which will give me 1157.0176, something like that. And I have to divide this with my true airspeed. So if I divide it with 180 as given on my question, the answer will be 6.4278. Still, the closer number will be 6, but as I said, like, it is not really worth risking during your examination. So really be careful about if it's the true heading or true track. Know the difference, what you're working with, then you're good to go. Our routing is along the airway November 562 from Turnberry, TRN, to Makarnish, MEC. What is the distance and magnetic course from waypoint Heron to MAC, like MEC? So basically, you need to spend time only finding the locations. Basically, if you have a map and if you work on that, it's much more simpler. I highly recommend that you try to find the specific points on the map with the coordinates to make it faster, and it will be easier for you during your examination also, because you want to spend less time as possible. So if I open my annex right here, so basically it asks us the waypoint from Heron to Mac. So the trick here is it also gives us the Turnberry VOR on the question, and it's basically asking only from the waypoint Heron to Makarnish DME. So basically you need to focus on the number 23, which is nautical miles, like the distance between the Heron and the DME, and between the Heron and Turnberry VOR DME is 8 nautical miles with 287 degrees. And you may wonder the number 31, which is written above the waypoint, like next to 23 nautical miles. Basically, it is the total distance between the Turnberry VOR DME to Makarnish DME. So you need to know these difference between that. So basically it was asking from Heron to Makarnish, so the answer will be 287 degrees with 23 nautical miles. Simple as that. Just you have to spend time finding where is the locations. Like my recommendation is you have a map, or you try to get used to the map. You can just do random coordinates and you try to find them on your map. You can do it with your friends or something like that. That's the only thing comes to my mind to help you, basically. But basically it will help you pick up the pace. Yeah, good luck. Given a variation of 3 degrees east and the information as indicated in the navigation plan, calculate the wind correction angle, WCA, and ground speed, GS, on the route from the CDA to the top of descent. Okay, so first of all, we have to check the annexes that we have right here. So since the question is asking for CDA to top of descent, which is TOD on this one, we only have to work with these ones. And also, as you can see on the navigation plan, 3 degrees east variation is already given on the question. So first of all, we know our true track, which is 304, and as you can look on the right hand side, we have the wind speed 330 degrees with 58 knots, and we have the true airspeed 414 knots. So basically what we have to do is we have to take out our flight computer once again. You want to put it on 414. Probably you will be using your high-speed flight computer, so it's basically the other side of the chart here, and you would like to put it to 58 minus 414. So basically you want to put it on the 356. I already did it right here. I'll show you. Yeah. So this is your wind. You have to put it with the wind direction. So this is your wind and your ground speed. So what you have to do next? Since we know our true track is 304, so I have to just rotate this to 304, and I get around 361 with 4 degrees to the left. So remember, the drift, I'll take note, is 4 degrees left. Yeah, and our ground speed will be like 360 something. Like, it's really close to there, to be honest. Be careful with the question. The question is asking for the wind correction angle. So if you're drifting with 4 degrees left, basically you need to do 4 degrees right correction. And the only answer we have here is the answer C, Charlie. So 4 degrees right, and ground speed is 361. So that's it for this question. During an IFR flight at an altitude of 3,300 feet and a transition altitude of 3,000 feet, given that the current QNH is 991 hectopascal, the outside air temperature at the aerodrome with an elevation of 179 feet is plus 8 degrees Celsius. The magnetic track is 182 and the variation is 4 degrees west. What is the minimum flight level the aircraft can be flown at? Alright, so first of all, what we have to do is the temperature correction. So let's start with that. For temperature correction, we know that in the sea level we need to have 15 degrees Celsius by the ISA standards. And every 1,000 feet you need to have minus 2 degrees Celsius to compensate for the cold air above. So basically 15 minus 8, we know the ISA will be minus 7. And because of our rule, what we have to do is we need to add 4 times minus 7. I mean, we can just say 7 times our altitude, which is 3,300 feet. Normally you need to decrease, like, okay, let's do like that actually. 3,300 feet minus the aerodrome altitude, 179, equals 3,121. But you need to divide it by 1,000, so it will be, because of the rule of the calculation, so it will be 3.121. So if I multiply all of these numbers together 4 times 7 times 3.121, it will be equal to 87. So 87 feet. Alright, as we know, if the air is colder, then you are actually flying lower. So we want to be on the safe altitude, so basically we have to add this number to be safe. So I will put here plus. By the way, if I can find the picture, I will add it on the video, which explains that when you're in the cold air, it is actually lower, and if you're in the more warm air, you're actually higher, than like your true altitude basically changes. Probably I will find the picture, so probably you're seeing it right now. So let's continue with the question. We also have the QNH over here. Yeah, and since we know the QNH on flight level is standard, so it will be 1013 minus 991. So in this question it didn't give us, we need to multiply it by 30, or sometimes it's 27, it depends on the question, but I always go with 30, so 22 times 30, which will give us 660 feet of deviation. Again, right now the QNH is lower than the standard, so that's why we have to edit. We are actually lower than the standard, so that's why it will be plus, just to be safe from the terrain. Alright, so the altitude we have currently is 3300, so plus 87 plus 660 equals to 4047. The minimum altitude that we can fly as IFR aircraft will be always with 0. If you're flying with VFR, if you're flying as VFR rules, basically you have to fly with 500. For example, if you want to fly at 2000, if you're VFR, it will be 2500, and vice versa for IFR. So basically, right now we have 4047. I will just take a note here. 4047 feet. Yes. And it is very important to not jump on the flight level 50 on this question, because it also given us the magnetic track. As we know, when we are flying towards the east, it will be odd number, and when we are flying to west, it will be even number. So since we know that we are flying to west, so it should be even number. So flight level 50 is not possible, and the nearest answer will be flight level 60. So the answer will be flight level 60, and as you can see, the answer is flight level 60. Basically, you have to keep it in mind that it is magnetic track that you're looking for, and you need to do the calculations one by one, and you shouldn't skip anything during your calculations. So please take your time to memorize these kind of questions, because during my ATPL examination I also had a lots of similar questions, and if you're really good at it, it's basically 3 points for you guys. So good luck on your examination. So that's it for today. Thank you very much for watching, and the tips that I would like to give it to you is, when you see the annexes or the question, within 1 to 2 seconds, if you know what to do next and what to come up with, then you're good to go for your examination. But if you're not, I strongly recommend that you focus on those parts. Anyway, thanks again very much for watching, and see you on the next video. Goodbye.